Completing a nearly 30-year marathon, NASA's Hubble Space Telescope has calibrated more than 40 milepost markers of space and time to help scientists precisely measure the expansion rate of the universe. You can click on the I button on the top right corner of your screen to watch top 50 Hubble images. Pursuit of the universe's expansion rate began in 1920s with measurements by astronomer Edwin P. Hubble and George Lemaitre. In 1998, this led to the discovery of dark energy, a mysterious repulsive force accelerating the universe's expansion. In recent years, thanks to data from Hubble and other telescopes, astronomers found another twist. A discrepancy between the expansion rate as measured in the local universe compared to the independent observation from right after the Big Bang, which predict a different expansion value. The cause of this discrepancy remains a mystery, but the Hubble data, encompassing a variety of cosmic objects that serve as distance markers, support the idea that something weird is going on, possibly involving brand new physics. Nobel laureate Adam Reiss of Space Telescope Science Institute and Johns Hopkins University in Baltimore, Maryland said, "You are getting the most precise measure of the expansion rate for the universe from the gold standard of the telescope and cosmic mile markers. This is what the Hubble Space Telescope was built to do, using the best techniques we know to do it. This is likely Hubble's magnum opus, because it would take another 30 years of Hubble's life to even double this sample size." Reiss leads a scientific collaboration investigating the universe's expansion rate called HUES, which stands for supernova H0 for the equation of state of dark energy. Reiss's team's paper, to be published in the special focus issue of Astrophysical Journal, reports on completing the biggest and likely last major update on Hubble's constant. The new results more than double the prior sample of distance markers. His team also reanalyzed all of the prior data, with the whole dataset now including over 1,000 Hubble orbits. When NASA conceived of a large space telescope in 1970s, one of the primary justification of the expense and extraordinary technical effort was to be able to resolve Cepheids, stars that brighten and dim periodically, seen inside our Milky Way and external galaxies. Cepheids have long been the gold standards of cosmic mile markers since the utility was discovered by astronomer Henrietta Swan Leavitt in 1912. To calculate much greater distances, astronomers use exploding stars called Type 1a supernovae. Combined, these objects build a cosmic distance ladder across the universe and are essential to measuring the expansion rate of the universe, called the Hubble constant after Edwin Hubble. That value is critical to estimating the age of the universe and provides a basic test of our understanding of the universe. Starting right after Hubble's launch in 1990, the first set of observations of Cepheid stars to refine the Hubble constant was undertaken by two teams, the HST Key project led by Wendy Friedman, Robert Kennicott, Jeremy Mould, and Mark Aronson, and another by Alan Sandage and collaborators, that used Cepheids as milepost markers to refine the distance measurement to nearby galaxies. By early 2000, the teams declared mission accomplished by reaching an accuracy of 10% for the Hubble constant, 72 plus or minus 8 km per second per megaparsec. In 2005 and again in 2009, the addition of powerful new cameras on board the Hubble Space Telescope launched Generation 2 of the Hubble constant research as teams set out to refine the values to an accuracy of just 1%. Several teams of astronomers using Hubble, including HUES, have converged on a Hubble constant value of 73 plus or minus 1 km per second per megaparsec. The team measured 42 of the supernova milepost markers with Hubble, because they are seen exploding at a rate of about 1 per year. Hubble has all practical purposes logged as many supernova as possible for measuring the universe's expansion. Reiss said, "We have a complete sample of all the supernovae accessible to the Hubble's telescope seen in the last 40 years. So what is the weird physics here? The expansion rate of the universe was predicted to be slower than what Hubble actually seen. By combining the Standard Cosmological Model of the universe and measurements by European Space Agency's Planck mission, astronomers predict a lower value for the Hubble constant, 67.5 plus or minus 0.5 km per second per megaparsec, compared to the SHOES team's estimate of 73. Given the large Hubble sample size, there is only a 1 in a million chance astronomers are wrong due to an unlucky draw, a common threshold for taking a problem seriously in physics. This finding is untangling what was becoming a nice and tidy picture of the universe's dynamic evolution. Astronomers are at a loss for an explanation of the disconnect between the expansion rate of the universe versus the primeval universe. But the answer might involve additional physics of the universe. Such confounding findings have made life more exciting for cosmologists. 30 years ago, they started out to measure the Hubble constant to benchmark the universe, but now it has become something even more interesting. NASA's new Webb Space Telescope will extend on Hubble's work by showing these cosmic milepost markers at a greater distance or sharper resolutions than what Hubble can see. It's time for Astronomy Word of the Day. Cepheid Variable. Cepheid variables are luminous stars 500 to 300,000 times greater than the Sun, with short periods of change that range from 1 to 100 days. They are pulsating variables that expand and shrink dramatically within a short period of time, following a specific pattern. Cepheid variable, one of a class of variable stars whose period of variation are closely related to their luminosity, and that are therefore useful in measuring interstellar and intergalactic distances. Thank you for watching and subscribe to my channel for more interesting videos. You can check out my Instagram page for amazing facts and information on astronomy. Have a good day.